Hey everybody, welcome back to part 3 of inverse functions. And in this video, basically we're just going to try to find the inverse of 2 more functions. And there might be a fourth video for another time where we verify inverses using a property, and I might include that just because we may be asked to do it on a district-wide test. Okay, so look. This is a different type of function here. It says find the inverse of the function, and we're giving a square root function here with an expression inside of it, x minus 5, and we have our steps we could go through and everything like that. This one may have an issue at the end, and I'll talk about it, but let's get right to work on this. And I'll go through the steps, and I've already prepared a graph, so if you're wondering what that looks like, if you're not familiar with square root graphs, that's what the square root of x minus 5 looks like. It is 1-to-1, so we don't have to worry about any of that, and we'll go right to work on it, okay? So we're going to take a look to begin with. We're going to go right through the steps. I like to write the function up here at the top so we'll know who we're working with. So the guy we're working with here is square root of x minus 5. And step 1 says replace f of x with y. Right. Step 2 says solve this thing for x. All right, so we know to get rid of square roots, we have to square things, right? And we can square both sides of this equation, and I'll get y squared equals the square root squared gives me what's inside, and we get x minus 5. And to wrap up this solving process, we need x by itself, so we get that. Add 5 to both sides. Step 3, interchange the variables. So I'm going to put y on this side, that's my x now, and it's equal to x squared plus 5. Okay? All right, so if you think back here, remember the range of this one is the domain of this one. So if you look at the range of f, and it might help for you guys graphically, 0 to infinity is this range, okay? So the range of f, I'm going to put a cap r here, is 0 to infinity. That's the domain of this one. See, if we kept this like it is, f inverse is x squared plus 5, that's not the correct inverse function. We have to restrict his domain, and we'd have to put x is greater than or equal to 0. Because remember, his range is his domain. And that would give us the correct inverse function. And I'll demonstrate that with the graph. But I don't want to get too long because I want to get one more function in this video because I don't want to have a part 4. All right, so if we were to go ahead and graph, remember we're supposed to be symmetric to the line y equals x. All right, now if I was to come down here and graph y equals, or f of x is what we're using, x squared plus 5. You can see that it needs that domain restriction. It just isn't right. So we needed to put that in, and I do have my button set up to work today. And there you go. You see the symmetry like you wanted it. And that one's done. Okay? So that's how those are taken care of. I don't think I'm going to graph this next one, but let's take a look at example 4. And this one, the tricky part of this one, I think, is part 2, solving it for some people. This one doesn't have any tricks in domains and ranges or anything like that. There's a trick, and just the algebra might get tricky for some folks. So we'll go through this one together and use the same steps. So we're going to write this on our clipboard here. Let me clear this thing out. And we're going to put f of x equals 3 over x plus 2. Okay? We're going to go through the same steps. You know, this gets repetitive, right? Replace f of x with y. Okay, and step 2 becomes our new issue. We start solving. Now, I don't know how good you guys are with rational expressions like this, but basically the thing to think about here, the way to work with this is you can think of cross multiply. Remember back in the day when you learned that? Or you can think of clearing the fractions. Multiply by the LCD, right? The least common denominator. And when you multiply both sides of this by the LCD, you have to multiply y by x plus 2. You get y times x plus 2 equals, well, when you multiply this side by x plus 2, it cancels the x plus 2. So it's just equal to 3. Because remember, we got to break x out of this denominator. We got to get it by itself. And the first step to doing that is just get him out of that denominator. So multiply by LCD, right? Multiply both sides by LCD, which is x plus 2 in this case, right? And you can think of cross multiplying. That would also work. All right, so now we have xy, distribute now, plus 2y is 3. Okay, so we want to get x by itself. So the next step here is to get this 2y term on this side. Then finally we'll be able to divide. If we divide right now, that's not going to happen. So the next step here is xy is 3 minus 2y. And finally we can divide by y here. So we'll get to x equals 3 minus 2y over y. And step 3 tells us interchange our variables. I'm going to skip a little bit. I'm just going to call it f inverse now. So I'm running out of space. And it's equal to 3 minus 2x over x. Okay. So the rational ones are a little bit tricky. You can cross multiply. You got to distribute and do things in the right order. What I need to do now, and this is one that might be smart to verify for us. I mean, we want to know if just, even though this is not a proof, but an example of the inverse working might make us feel better. And just remember, we got 3 minus 2x over x. I'm going to rewrite it on a fresh screen here so we can test it. So our inverse function we came up with, well, let's write both of them. We got f of x, and he was 3 over x plus 2. And all that hard work we did, we found that f inverse was actually 3 minus 2x over x. Okay, so let's run a quick test on this thing and see what happens here. I'll come down here and do my mapping drawing. We're only going to do, I guess, one number will be good enough. And it doesn't matter what you pick. Obviously, we might get involved with some fractions here. So I'm just going to pick something, say 4. All right, so I'm going to say f of 4. I'm going to plug 4 into this one. And I get 3 over 4 plus 2, which is 6, right? And I get 1/2. Okay, so you might want to avoid getting a fraction because you got to plug that fraction back into this one. But let's just continue with what we've got. So we sent over 4. He went over, became a 1/2, right? Now let's see if 1/2 comes back to a 4. Now this is proof, but it's a good indication things are working, okay? So we're going to get, we want to try f inverse of 1/2. And we better get 4 or this thing's not working. So we get 3 minus 2 times 1/2 divide by 1/2, right? All right. 3 minus 2 times 1/2 is 3 minus 1. So at the top we got a 2. And we're going to divide by 1/2, which means flip and multiply, which makes it a 4. It checks out. So f inverse does take it back. And that's an indication that our inverse function is working. And this should get you out of the woods on this for a bit. I'll update the lesson notes. I do have a corresponding, not SchoolNet, we have a corresponding Delta Math, so try it. And if you have any trouble, join me in a Zoom. And my schedule's the Apple. So go in there and look. You can join any Zoom you need to, and I'll get it straight for you, okay? Thanks for watching.